Okay, we are going to solve this system of equations by finding a row echelon form for the augmented matrix. So this is a system that has three variables, three equations. Let's first start off by writing the augmented matrix. 3, 7, -11, 44, and 1, 2, -3, 12, 4, 9, -13, 53. Okay, we are allowed to do three different things to make our rows in our matrix. We can switch rows around, we can multiply a row by some number, or we can multiply a row by a number and add it to another row. And so what is important here is what our goal is. For regular row echelon form, not reduced row echelon form, but for the regular row echelon form, this is our goal. We want a diagonal of ones with zeros underneath our diagonals, and then all of the rest of the numbers can be numbers. So this is where we're trying to get to. This is where we're starting. So to do this properly, we need to start at the top of this where our 1 is and then work our way down. And so we basically do it a column at a time. For our first column, we need to get the 1 first. That's going to help us to get these zeros. For the second column, we get the 1 first. That's going to help us get the 0 at the bottom. And then last, we're going to get the last one. So here, if I want a 1 in this spot, I could multiply everything in this row by 1/3, and it would give me a 1 right here, but then it would also give me some fractions, and I'd have to deal with the rest of the problem. So instead, let's switch row 1 and row 2, because row 1 has a 1 in the first column. And if we make them switch places, that's an awful R. If we make them switch places, then that'll be much easier than having to deal with those fractions. The notation to do this is we write row 1 and then we put a double-sided arrow or a double arrowed line, whatever you want to call it, and then row 2, because we're telling whoever's looking at this, I switched the rows for row 1 and row 2. So I'm going to write 1, 2, -3, 12, and then now I write this row, 3, 7, -11, and then the third row I didn't change, so I leave it alone. Okay, so if there is a 1 in the first column, but it's not in the first row, your first step should always be to try to switch those rows around so that you may end up with less fractions than you otherwise would. Now we need to get a 0 right here where this 3 is. And so I can't just subtract 3. That doesn't work. I can't say, oh, let's subtract everything in this row by 3. That doesn't work. We could try multiplying by something, but we'd have to multiply by 0. Then everything would be 0, so that doesn't work. What we're going to do is we're going to take row 1, and we're going to multiply it by a -3, and then add it to row 2. Here's how we write that. -3 times row 1 plus row 2. Okay, and so what I find helpful to do is actually multiply this row by -3 and write it up above it. So that would be a -3, -6, 9, and -36. Now what we're going to do is we're going to add it to the second row. Now when we do this, the first row doesn't actually change. We're using the first row, but we're not actually changing it in any way for the next matrix we write. But for our second row, we are changing it. -3 plus 3 gives us 0. -6 plus 7 gives us 1. 9 plus a -11 gives me -2. And -36 plus 44 gives me 8. Then I would have the row 3 is the same because we haven't messed with it yet. Okay, so we got our next thing done. We've got a 0 underneath our 1. Now we need a 0 underneath that 0. So anytime we're getting zeros, it's going to look something like this. We're going to multiply a row by something and add it to the row we want to 0 in. So I would multiply the first row again by a -4, because -4 plus 4 is 0. So -4 row 1 plus row 3. Okay, and so row 3 is the only row that's going to change here. I'm just using row 1. So I'm going to multiply row 1 by -4 and just have a note up here that tells me what those are for while I'm adding. And basically that's so because the more things you try to do in your head, the more likely you are to mess up somewhere. -8 plus 9 is 1. 12 times -13 is -1. -48 plus 53 is 5. So we're done with our first column. Now we have to do this kind of strategically to make sure that we don't mess up that first column. So the next, and by doing what I told you down here, you'll be able to make sure you don't mess up that first column. You won't mess up what you've already done. We want a 1 in the middle, which it's already there, so we don't need to actually do a row operation to get that 1 in the middle. Then we want a 0 on the bottom middle. So I want a 0 right here. Well, there's a 1 right here that basically we're always going to use the row we just got a 1 in. So because there's a 1 in row 2, I'm going to multiply this row by a -1 and add it to row 3. So this will be a -1, this will be a +2, this will be a -8. Only the third row is changing because we're just using row 2, we're not actually changing it. So -1 plus 1 is 0, 2 minus 1 is 1, -8 plus 5 is 3, a -3, and close our bracket. So we're done with the second column because we've got a 1 and a 0. Our third column we actually are done with as well because it already has a 1 there. So we would write this now as a system of equations. Again, x plus 2y, and we're just putting our x's, y's, and our z's back in with this. Minus 3z equals 12. Y minus 2z equals 8, and z equals -3. So let's plug these back in to get our x and our y, because we know z is -3. So y minus 2 times -3 equals 8. That would be y plus 6 equals 8. So y equals 2. Plug y and z back into this top equation here. So x plus 2 times 2 minus 3 times -3 equals 12. So 4 plus 9 is 13. So I subtract the 13 from both sides, and x equals -1. So this gives me -1, comma 2, comma -3. Now let's do a reduced row echelon form for the augmented matrix. So this time our goal is slightly different. This time we want 1 0 0, 0 1 0, 0 0 1, and then these should be numbers. So that's just going to mean that we have to do a little bit more work than what we did the last time, which, hey, no big deal. Well, why does more work matter? So 1, 2, -1, 3, 3, 7, -3, 12, 2, -4, 3, -5. Okay, so there's our first matrix. Now, just like before, we're going to start with the 1, and then we're going to go down, and then we'll be done with this column. Then we still want to get the 1 in the middle, and then get the zeros. And it doesn't really matter which 0 in a column you get first. And we want to start with that 1, and then we want to get those zeros. So I already have a 1 in the first spot. That's good. Now I need to get zeros in these two spots. So I'm going to do, to get row 2, I need to do -3 times row 1 plus row 2. And then you could, if you felt confident enough, you could actually do 2 operations at once, as long as it's just when we're trying to get zeros. In no other way should you do more than 1 operation at the same time. It's not going to help, but we want both of these to be zeros so we can do those at the same time. So -2 times row 1 plus row 3. But if you do it this way, you have to make sure that you don't get confused. The first row is staying the same. I'm going to do -3 times the first row, and I want to add it to row 2. So that's going to give me 0, 1, 0, 3. Now I want to do -2 times row 1. So either like mark this out, what you had before, or erase it, or just put it in a different spot, I guess, so that you can tell the difference. -2 times row 1 would be -2, -4, 2, and -6. So that would give me 0, 0, 5, and I'm sorry, this is not 0, this is -8, because those are both negatives. -8. -4 plus -4 is -8. 2 plus 3 is 5. -6 minus 5 is -11. Okay, so we've got our first column done. Now we need to go to the second column. And actually, we already have a 1 right here in the very middle. And so we don't have to get that 1. Now we want to get the 0 in row 1 and row 3. So to get the 0 up here, I would do -2 times row 2 plus row 1. To get the 0 here, I would do +8 times row 2 plus row 3. So this last thing is always the row that you're trying to change. So our next matrix, we would multiply row 2 by -2, so this is still going to be 0. This will be -2. This will be 0, -6. So my first row, if I add those together, is 1, 0, -1, -3. The middle row does not change. And then now we want to do the last row. So not using those numbers anymore. I want to do 8 times row 2. So 8, that's not 8, that's 0. 8, 0, 24. So I want to add that to row 3. So 0 plus 0 is 0. 8 minus 8 is 0. 0 plus 5 is 5. 24 minus 11 is 13. Okay, so we're done with the second column. We've got 0, 1, 0. Now I want to get a 1 right here at the bottom right of my coefficient part of my matrix. To get a 1 here, I have to multiply by the reciprocal of this, which is 1/5. So I'm going to do 1/5 times row 3. So everything else stays the way it was. But here, well, if I multiply these by 1/5, it's still 0. 1/5 times 5 is 1. Then I'm going to do 13 times 1/5. And because these are matrices, unless you have like a 1/3 or something, as long as it's a decimal that ends, I'm okay with you putting a decimal. Like this would be a 2.6, because fractions can be kind of difficult to deal with in matrices. So 2.6. Now I only have one thing left. I need a 0 in this top right. And I'm going to use row 3, which I just got a 1 in, to get that. And since these are opposite signs and they're both 1s, I actually just need to add those two rows together. So I'm going to take row 3 and I'm going to add it to row 1. Because remember, row 1 is the one that we're changing, and so that's the thing that goes last in our notation. So if I add those rows together, 1 plus 0 is 1, 0 plus 0 is 0, -1 plus 1 is 0. And -3 plus 2.6 is -0.4. My other rows stayed the same as what they were. And because this is in reduced row echelon form, look, the only thing that has a value over here is my x. This is saying x equals -0.4. This is saying that y for the middle row equals 3. Z for my last row, that's 2.6. So this is the point, -0.4, 3, 2.6. So there is row echelon form and elementary row operations. Now we want to talk about solving systems with inverse matrices. So what we can do is we can split a system of equations into three matrices like this. So this was actually an earlier example that we had. And what we can do is we can split it up into its coefficients. So 1, 1, 2, 1, 1, 3, 1, 2, negative 1. This x right here is a multiplication sign. We times that by the letters we have, x, y, and z, and that equals what we have right here, the right-hand side of our equations, 11, 14, and 5. Now, if you actually go back and multiply these together, you get the left side of this system, because when we multiply, we do this one and this one, plus this one and this one, plus this one and this one, which is this. Okay, so it does actually work out that this is really this system of equations. Now, what we can do then is we can call a coefficient matrix A, the variable matrix X, the right side matrix B, which gives us this equation AX equals B. Now, if I literally just had an equation AX equals B where I was saying A and B are numbers, what would I do to solve that equation for X? I would divide by A on both sides. And I would get B divided by A, whatever that is, for whatever my situation is. But I can't divide matrices. All I can do is I can add them, I can multiply them by a scalar, that's about it. I can multiply them and I can multiply two matrices together, I can add matrices, and I can multiply by a scalar. So instead, then what we're going to do is we're going to say x equals A inverse times B. Okay, and we're going to use the calculator for this for the most part, because of the matrices that we're finding the inverse of are going to be 3 by 3 or more, and so I use A inverse and I times that by matrix B. So let's do that. Let's set that up with this system of equations we've got. So you're going to go to your calculator. And here's what we need. We need the matrix menu, which is right here. You press second, x to the negative 1, and you go over and you edit one of your matrices. So I can edit matrix A. And mine already has a 3 by 3. If you don't have any matrices in yours, you're going to have to type in 3, enter, 3, enter, and you're going to have to change it so that it gives you a 3 by 3 matrix. Matrix A is the coefficient matrix. So let's put in 1, enter, and see how it goes across the top like that. 1, 1, 2, and definitely check to make sure as you're going along that you're entering it correctly, that it actually goes to the next row when you want it to, and that kind of thing. Okay, but here I have my coefficient matrix. Now I want to go in and put in a matrix B for this right-hand side. So go to second matrix, and let's go over to the right to edit and down to B. We're going to put in, this has 3 rows and 1 column, so 3 by 1. And that gives us 11, 14, and 5. Okay, now we want, if you're trying to get out of a matrix, you need to do second mode so that it quits. You can't just like press clear and get out of it. We want to type into our calculator x equals a to the negative first times b. So you're going to go back to second matrix and see it says names. We're going to press enter and it's going to put matrix A right here in our normal part of our calculator. This is the inverse button that I have right here. X to the negative 1 will find the inverse for us. Then we're going to multiply that by matrix B. So I'm going to go back to second matrix and I'm going to come down here to B and I'm going to press enter. This is going to do the inverse of A times B. I press enter. It gives me 2, 3, 3. And so what that means is that X equals, and X was this matrix. Where'd my pen go? X was this matrix with X, Y, Z, and it equals 2, 3, 3. And so that means I can write this answer as a point. I can write it as 2, 3, 3. So that just solved that right there for me. And the reason that seems so much easier than probably what we've done in the past few examples is because I'm letting you use your calculator to find that inverse. If you had to find the inverse by hand and do the matrix multiplication by hand, this would be about the same intensity, I guess, of difficulty as the ones before this. So let's go on to some word problems. Um, one is fitting a parabola to 3 points, determine A, B, and C so that the points -1, 5, 2, -1, and 3, 13 are on the graph of f of x equals ax squared plus bx plus c. So what is happening here is they're telling us that if x is -1, then y is 5, or f of x is 5. And so what we can do is we can actually plug in our x's. So a times -1 squared plus b times -1 plus c, that has to equal 5. Then I can do the same thing for f of 2 equals -1, which is our second point. A times 2 squared plus b times 2 plus c equals -1. Then I do that with the third point. Okay, now we're actually going to have to figure out a way to solve this. I kind of like to use the way that we just did because we've only done it once now. So our coefficient matrix, if we have A, B, and C, well, A, the number in front of A is actually going to be, this is going to be like 1A minus B plus C, right? Because this -1 becomes a positive. So this will be 4A plus 2B plus C. This one's going to be 9A plus 3B plus C. So now that should make it easier to write our coefficients. So 1, -1, 1. 4, 2, 1. 9, 3, 1. There's our coefficients. This is matrix A. We're going to times that by, we wouldn't have x, y, and z here. We actually have A, B, and C. That equals our right-hand sides, whatever, 5, -1, 13. So in our calculator, we're going to end up doing the inverse of matrix A times matrix B, and that'll give us the answer. So second matrix, we're going to go over to edit, and I'm just going to use the matrix I used a second ago. So this is going to be, I don't want it to be 1, 3 by 3 still. And then 1, -1, 1, 4, 2, 1, 9, 3, 1. And then you go in and edit the other matrix. So this is 5, -1, 13. And the great thing about this is because the last thing I did was A inverse times B is I can just press enter and look, that's our new answer. 4, -6, -5.